I'm back again. This time we will be doing the DBE November 2020 paper 2. We'll be looking at question 5, which deals with the trigonometric graphs. We did a lot of this. It says here, the graph of f of x is equals to minus half cos x, and g of x is equals to sin x plus 30 degrees for the interval 0 to 180 degrees are drawn below. A, they told us the coordinate of A, and is the approximate point of intersection of the two graphs. All right, they told us that these two graphs here, they meet at this point here, A. The first question asks us to write down the period of G. G is this graph here. I told you that the number in front of these functions, the number in front of this function, which is A, is always your amplitude. So you ignore the sign here. If the sign is negative, you just take the positive value of it. So the answer here will be what did I say? Half is your amplitude. Half is your amplitude. And 5.2, write down the amplitude of... I skipped this question. Oh, my bad. I'm sorry. My bad. I think I did question 2 before question 1, but 5.1, it says write down the period of G. G is this graph here. G, as long as there's no number in front of x here, as long as there's no b here, or as long as there's no frequency here, the period of a sine and a cos will always be 360 degrees. If there was a frequency here, you would just say, 360 degrees divided by the number that is in front of x. 5.2 says write down the amplitude of f. We discussed it, and it is just a half. It is a number in front of this function here, and we always the amplitude is always positive. So if you see a negative sign in front of this, you just take the positive sign of it. 5.3, determine the values of or if we put in 180 degrees in here, and if we put 180 degrees into G, how much do we get? How much is this? Only 1 mark. In this type of question, we just say negative half of cos 180. They said minus, right? Just minus sine, where is it? Oh, sine x. Sine 180 plus 8, you will get a value of 1 here. Let me show you. Sine 180. And before you do this, make sure that your calculator is in degree mode. I forgot to put mine in degree mode. That's why it gave me a funny value. Make sure that your calculator is in degree mode. You see that D there. You must make sure that your calculator is set to degree mode. So if you do this, you will get a value of 1. So here you're just gonna write 1. Sorry about that. You're just gonna write 1 as your answer, and then use the graphs to determine the values of x in this interval for use the graph to determine the values of x in the interval for which f of x minus 10 is equals to g of x minus 10. Oh, they're talking about this point here. And remember what I said. When they see, they moved these two graphs to the right, since they said minus 10 degrees. If it was plus 10 degrees, they would have moved them to the left. Since it's minus 10 degrees, they move them to the right. So you add the x coordinate here of 130.9, you add it by 10, you get the new coordinate. Remember that the y coordinate does not change here, because we only changed the horizontal. We only did the horizontal shift, not the vertical shift. So the coordinate will be or you might just say for which values of x. Since they want only the value of x, you can write 140.9 degrees as your answer, since they moved these two graphs to the right. And here they want a solution for this. I'm gonna show you two ways on how to do it, but first let's determine the solution for this. What I'm gonna do here is that I'm gonna divide by 2 on both sides. I'm just gonna divide by 2. I'm just gonna divide by 2, and what I get here is that square root 3, I'm a square root of 3 over 2 into sine x plus half of cos x, because half of cos x, it is just cos x over 2, and I'm just going to say it's greater than or equals to 1 over 2. Oh, oops, you can see there. Why am I doing this? It's greater than 1 over 2. And then we are trying to reverse what they did here. We are trying to reverse it. So if you know your special angles, if you know your special angles, you'll know that 3 over 2 is the same as cos 60. Just say cos 60 on your calculator. You get, cos 30, not cos 60. Cos 30 in your calculator. If you press cos 30 in your calculator, you get this value here. So we can replace root 3 over 2 by cos 30. You can just say cos 30 sine x plus, if you know special angles, you know that 1 over 2 is the same as sine 30. So you just say plus sine 30 and times cos x. Yeah, times cos x is greater than or equals to half there. And then what do we do? Oh, since we have cos sine, you can use your what do they call your compound angles. Let me show you them in your formula sheet right now. Here it is. You can see them here in your formula sheet. You can either use this or this, but since here we have a plus there, since we have a plus here, and we have cos sine cos, we use this here. So we reduce it. What am I putting? Yeah, you use this here. So we use this here, and here we can say sine. Let's say x plus 30. Remember, is in degrees, is greater than or equals to half. So if you draw this graph here, or you just estimate not estimate, like you know where your sine x graph as a value of a half. It has a value of a half where x is 30 degrees. Sine 30 degrees gives us a half, and sine I think sine 150 again. Let me check. Sine 150. Yep. Sine 30 and sine 150, they give us half. So here you can just say x is equals to, since they say this graph must be greater than or equals to, so you can just say x equals to 0 degrees or x equals to 120 degrees, because 120 degrees plus 30 degrees gives us 150 degrees. I hope I did not confuse anyone here. Like I promised you, I'm going to show you two methods on how you solve it. And here's another method. I tried it here. there it is, sorry, there it is. And here I said I copied down the way it is, and I squared both sides because I want to use my trig identities. And when I FOIL this here, I get this expression here. This is 2 times root 3 sin x cos x. And when I moved this one here, I moved this one to the other side, it became -1. I used these trig identities, the one that says sin squared x plus cos squared x is equals to 1, and sin squared x is equals to 1 minus cos squared x. So minus sin x squared is equals to -1 plus cos squared x. Like here, if I move this +1 to the other side, it will become cos squared x minus 1, and I will be left with minus sin squared x is equals to cos squared x minus 1. And where I saw cos squared x minus 1, I replaced it with minus sin squared x there. I hope you can follow it. And these are like terms. I added them. I said 3 sin squared x minus sin squared x. They gave me 2 sin squared x, and I left everything here as it is. And I said it's greater than or equals to 0. Here what I did is that I divided all sides by 2. That means that's why this 2 here went away, because I divided all sides by 2. And what did I do here? Oh, here I moved this this whole expression here. I moved this to the right, and I said sin squared x is greater than, what did I? Oh, I just equated it. I removed this greater than or equals to 0. So I just removed this greater than or equals to, and I replaced it with equal sign here. And you are not allowed to do that if here it was greater than 0. But since we have greater than or equals to, you can do this. It's totally fine. You can do it. And from here, I divided both sides by sin x. If I divide this side by sin x, I'm left with sin x. If I divide the right side by sin x, they will cancel, and I'm left with cos x here. Negative root 3 times cos x here. From here, I divided both sides by cos. Sin over cos, it gave me a tan x, and negative 3 root of cos x. Negative square root of 3 times cos of x divided by cos x. Those, they will cancel. I'm left with tan x is equals to negative root 3. And when I take the inverse tangent of negative square root of 3, I get that x is equals to negative 60 degrees plus 180 degrees plus k. Times k. Remember that k is integers. So we don't want the intersection in the negative. We don't want the, what am I saying? We don't want the values that are in the negative x-axis. We want the solutions that are here in the positive x-axis. So to find those values, we just say minus 60 degrees plus 180 times any integer. You can put 0 there. If you put 0, you get minus 60, which is not what we want. If we put 1, you get 120 degrees, which is one of the solutions that we got in the first step. So we can say, therefore, x is equals to 120 degrees. Let's see if we can find other solutions. Let me put 2 here. If I put 2, I get 300 degrees, which is out of our range. Remember, our range is from, not range, our interval is from 0 to 180. So 300 is greater than what our interval is. So let's move to negative integers. If here I plug in, let me say I plug in -1, let me see what I get. If I plug in -1, I get -240, which is not what I want. And let me plug in -2. is also out of our range. So here our answer will be x is equals to 120 degrees, like this here. Or you can just give them your general solution for this. Is also fine, but this is how you should have answered this question there. And I believe I'll see you in the next video. Bye.